Hey guys, Mark Allen, BHSpringSolutions LLC, BHSpringSolutions.com, back again for a special session series of High Power University, and this is the fourth or fifth, depending on how you count it, Turkish high power clone that is now in the United States market. We have two of them. They are serial numbers 605 and 607, so there's an odd man out. But we did pick up two of them. They are brand new, and we're now going to we're starting this evaluation a bit differently. We're not going to start with a shop review. I did about a 10-minute review of each of these handguns. They are, for all intents and purposes, we believe to be identical as they can be. They both have, get this, 9-pound average trigger pulls. That's higher than we've ever seen in any high power history from any manufacturer, frankly. And it does seem to be like that lion's share of that 9 pounds is in the stability of the Sear. The Sear is just, it's hard to move it. We did encounter one other thing though, and this one I'm going to talk about briefly. This is a Type 1 Sear lever model. That's a non-muzzle drop safe Sear lever. This one, FN Browning abandoned that Sear lever in 1989 with the introduction of the Mark III or Mark III's. It's known as, and Springfield SA35s also used this Sear lever. That Sear lever, which we will show in a shop review in detail, what it's supposed to be like and what these are like. And if you can imagine a lever on an axis, which is in this case a pin, and this lever design is supposed to be floating. In other words, it's supposed to be, what's normal is you can kind of shake the slide when it's off the gun and it'll rattle back and forth. And it should have no artificial resistance on it of any kind. These don't float. These are non-floating, floating Sear levers. And frankly, I take this subject with utmost seriousness, because that Sear lever contacts, when it's movable, non-positively positioned, not a Type 2 Sear lever with a spring, not BH's Type 1 safety Sear lever with spring, which means the spring positively positions the Sear lever. It keeps it away from contact with the Sear until it's time, until the trigger has been manipulated or has been pulled and manipulates the Sear. So, we replaced out the Sear levers. We did not touch anything else in these two handguns. What we changed out is a margin of safety. This is not, it does have nothing to do with reliable function. And the reason we did that is because I forbid Type 1 Sear levers that have resistance on them. Frankly, Type 1 Sear levers that don't have a positively positioning spring, like our safety Sear lever design does, we don't load them. In the early days of BHSpringSolutions, I can tell you I have so many experiences of Type 1 Sear lever models firing because I let the slide go to load around and it fired. And some people say this is hammer follow. No, that is Type 1 Sear lever bouncing on that Sear when the slide goes forward, causing a release of the hammer. And I have had magazine dumps where, I mean, you can't believe how fast these things can function. It's like, and it's over, and it's empty. And you stand there and you, what just happened? Like for a minute or a second or two in your head, what was that? What happened? Because it happens so quickly, and it's completely unpredictable. When that Sear lever is truly floating, not encountering resistance from its environment, and you have full good Sear spring pressure on the Sear, keeping it still so it will tolerate that contact that frankly is a bad idea in the first place, and it's the reason why FN Browning replaced that design finally in 1989, along with the fact that it made a muzzle drop safe situation. This sort of thing that we encounter, frankly, with a lot of the reverse engineered clones, I feel like I look past a lot of stuff because there's a lot of stuff that is, you know, it's it's just sort of okay or marginal. We're not looking past this one, and I'm never going to look past this because it is that serious. The idea in the very first place that Diodone Safe, way back, when the P35 first came out at FN Browning, the idea of having a sear lever that could contact the sear before being manipulated by the trigger, that is a direct contradiction of a guidance from John Browning in his last handgun patent. And when BHSpringSolutions, with help of Leon Hubert, our chief weapons modifications designer, introduced our Type 1 safety sear lever with spring, this resolved a direct contradiction with John Browning's guidance, finally. And so, in our opinion, this is a marginal design at best, because a non-positively positioned sear lever in a high-power pistol means that you are going to have contact sear lever to sear every time that slide goes forward. And if it's a rather benign floating sear lever, that will never matter until, probably decades down the line, when the sear spring finally starts to give up all of its enthusiasm. The sear is not as stable, and now that floating sear lever becomes, a bigger part of the picture. In this case, these sear levers aren't floating. They're movable, but they have resistance, and that means they're going to tend to contact that sear and hit harder. And again, this is the kind of thing that, in the early days of BHSpringSolutions, I personally encountered so many high efficiency firing scenarios. High efficiency meaning, one or more or all rounds leaving the handgun with one trigger pull. And the older high powers, the Type 1 sear lever, where everything has not been maintained and everything is not right, and that sear lever is still in there and it's still floating, these things are hazardous if you don't have full resistance on the sear by the sear spring. So we are going shooting with these two out of the box, as stock as I will allow them to be loaded. And so it's BH's Type 1 safety sear lever with spring that is in both of these handguns. No other changes, no spring changes, no nothing. We do have magazines here that are look like the same design as in the Inglis high powers that we did the evaluation on. We will be testing with those. And today we're going shooting, and we're just going to see what happens with these things right out of the box. Okay, I'm not even sure I even really properly identified what we're testing here. I can't pronounce the manufacturer. I would butcher it, and I don't want to do that. This is an import by Century Arms, made in Turkey. They call it the Centurion 14. Sounds like this is something they made up special for Century Arms. And again, I can't pronounce the manufacturer. We got two of them. We've got 180 rounds loaded up. One thing we're not going to be doing today is, if we have any malfunctions, we are going to be stopping, and we don't chase, I'm not going to chase their problems with our ammunition, is what I'm saying. So we're ready to get started. Dave, take it away. I'm going to be back here kind of getting this angle on the action. Oh, stop.
So, magazine follower issue, it just didn't lock up.
Slide did not lock back?
Yeah, so the magazine follower did not lock the slide stop up.
Okay, okay. Let's go ahead and continue. 3 to 6 foot extractions, what we were seeing there. Not a lot of consistency. seeing that 3 foot to about 7 foot extraction is kind of where I've been seeing this so far. About 3 to about 8 foot extraction so far on that one.
Trigger is horrible.
We're getting a lot of extraction in sort of a variety of different directions at this point. Had one there that seemed like it barely lopped out of the pistol. The extractor didn't have a great hold on that round. Switch places with me, Dave. Is your finger getting tired yet?
Bruised. A 9.5 to 10 pound trigger pull on a very narrow trigger is
Something else.
It's
ain't it?
challenging.
Throw me 20 more rounds in there. We could see 200 out of this. Dude, you have taken out that target, man. Absolutely chewed it up. I don't have enough ammunition to do that on the other target. You can't see it in the camera. We've got lines on the concrete out here. Each one's a foot apart, and it tells us about how far these extracting empty shell casings are going. And so far, I've seen everything from about a foot to about 8 foot, about 8 foot plus. we're getting extraction just sort of in this broad range. We just had one there just a tick over 4 feet. We've been exceeding 8 feet. You saw that one. That one probably showed up in the picture. That's an indication that we have an extractor that's not holding that casing each time the same on its way back to the ejector. So that's the reason why we're looking at this consistency of extraction. Not only consistency of the extraction, but consistency of the flight, consistency of the way they're leaving the handgun. And so that's what we're finding out today. Okay, guys, we just shot 200 rounds through here. And if we can, I want to load another 100. Okay, the only cooling time we had was how long it took us to load up another 100 rounds. These are going to be going through a bit faster. And we'll see, maybe this can go 300 rounds without a fail. I can tell you, typical slide frame relationship in an FN Browning high power, somewhere around 175 to 250 in that range. Normally you're going to have the slide and frame seize up from heat, which is a normal thing because those are very tight fitting, well fit slides and frames. We're going to find out what happens with another 100 out of this Centurion 14. Trigger is a hard thing to control, guys. What's our extraction like? About the same as it was?
Yeah, 5 to 6. Couple in the 7, couple in the 4.
Okay. Sorry, that was a fail. That was not empty. That was a fail to extract. I mistook it for a. I mistook it I thought I was empty because we had that last magazine to make 100. It was less than a full mag. That was a fail to extract. So first malfunction failure, but that's what that was. Okay, 300 rounds. What was our extraction distance on those last ones?
5 to 6.
5 to 6.
Still?
Okay.
Yes.
Okay. That's 300 rounds with a bare minimum of cooling time between loading up. One failed to extract out of 300. The slide and frame shows no sign at this point of getting too cozy with each other. We're not seeing any slide velocity slow down or anything. That tells us a bit about, slide frame fit. There's plenty of room between the slide and frame in this one. Okay, we are going to go to our next session.
Hey guys, Mark Allen, BHSpringSolutions LLC, BHSpringSolutions.com, back again for another special series in High Power University. This is all about the Century Arms Centurion 14, and this is Turkish import number 5 as we're counting them. That would include the Tissos BR9, the Springfield SA35, the Gersan MCP35 and PI models, the Inglis L9A1 and P35 model, and this one. And this one is the most recent. We have with us serial number 605, 607. This is very early production that we're looking at here. One serial number missing between the two that we got, and yeah, that's a pretty interesting thing. And this is how they're coming. We have one 15-round magazine. That's not a Metgar magazine. They came with a cleaning brush, a patch rod, another buffing rod, trigger locks, kind of all the normal stuff. And compact as you see them right here. And so we're going to dispense with the carry case part, and we're going to make a little room for ourselves and talk a little bit about what we experienced and what we found out of the box. Average trigger pull break weight of both of these models came in right at 9 pounds. That would be the highest in history, basically, that we've seen. The old FN Browning product was very often, in this, say, 7.5 to 8.5 pound range, kind of typical out of the box. Sort of kind of where the Gersans are today, a lot of them that are the magazine disconnect models. And so, yeah, that's what it is. That is completely solvable if that's too much of a trigger pull for a person. Just one point of reference, what I'll say about that is the high powers trigger has what we call stages. This is take up. And for you guys that have high powers and have had a magazine disconnect, that is a really ratty, gritty one. But there's not an unusual amount of force that I'm being required on my finger to pull through the take-up. However, I get to the wall and I want to start to cause the sear to move so the hammer tooth can slip past the sear and go home to the firing pin. And that is a stiff wall that I'm encountering right there. And we're going with, the majority of that 9 pound trigger pull is happening right where you're seeing me pull right now. And I am pulling with some intensity, and that is what it takes. So, yep, 9 pound average on those. Again, this is something that we can handle. The issue about the magazines, these are identical except they made the red plastic follower red instead of black as in the Inglis's, but for all intents and purposes these match the Inglis design magazines. And the thing that we've had that has not been necessarily like 100% malfunction but still not correct function is these have a redesigned spring in them. They're shorter than a 15-round Metgar magazine, and when the follower is all the way up like this, that's when that spring has the least amount of influence. And we're experiencing that follower kind of running out of influence, and you can kind of see the resistance on that follower isn't very robust, actually. This is a Metgar here, and I've got quite a bit more resistance. The follower tends to stay a little more level when it's being depressed. So we won't, any of these handguns that we optimize and make into BH masterpieces or BH advanced carry firearms, we won't be shipping out these magazines that are coming with the firearm. We will be using in favor of the Metgar design. Both of these firearms were extensively oiled inside, and when I went ahead and removed both extractors to kind of inspect that area, one of the extractors dripped oil when I pulled it out. So very little risk of these rusting on their way to the United States. I would say they're just bathed in it. And that's one thing, the first thing that we're going to advise, that anybody who gets one of these firearms really should do everything they can to get all of that extra lubrication out of there before you start shooting. The black stuff that happens inside your gun when you start shooting, that's like a magnet, and it starts building up, then it gets hard, then it gets, kind of goes downhill from there. I want to talk about one concern right up front very early, because we want people who watch this and have these handguns just to be aware of one thing that we did find. And the one thing that I'm talking about here is the Sear lever design, and it is the old, we'll say FN Browning goes way back to 1935 Sear lever design that persisted until about 1989. And the Sear lever is right here. The function of that Sear lever is your trigger lever when you pull the trigger in the high power, you see that rise up right there. When your magazine is in the handgun, it's in the rearward position. You saw that just move. Now when I take the magazine out, you'll see it come forward. Now it's forward, now it's rearward. When it's rearward, it can contact this Sear lever. That's what allows the Sear lever, sort of works like a teeter-totter on an axis. That Sear lever then engagement point is right here on the Sear. And this Sear being movable or less movable, taking more influence, that's the wall. That's where I'm encountering that stiff resistance, because this Sear is having, you know, a lot of resistance behind it, and it creates a very, very hard point in the trigger in order to get past. So again, that's something that we can work with, but just an observation here. But the thing I want to get back to is the subject of this Sear lever. And the idea of this Sear lever in the beginning, which frankly is not a very good idea to begin with, but the idea was for this Sear lever to be floating. And this Sear lever should not, you know, kind of stay in place when I'm doing this. And both of the Sear levers were not truly floating. These had you know, marked resistance on the Sear levers themselves. The way that the original design got away with this is every time, first of all, let me say, when a Sear lever is not positively positioned, that means that engagement point right there comes in contact with this Sear right here every time the slide goes forward. And this is not a disputable thing. It happens. And it's a direct contradiction to John Browning's guidance in his last patent application, which said the Sear lever must not be touching the Sear before it's time, before it's manipulated by the trigger lever. And his design had a way of doing that. Later in the Mark III series from Browning, the Sear lever became like this. And it's the same Sear lever arrangement used in the Inglis and in the Gersans. And it has a spring underneath it, and you see that coming back. It positively positions. What that means is every time this slide goes forward, that Sear lever absolutely cannot contact the Sear. And that's a big, big difference. If you have ever heard of, if you read online, malfunctions with high-power pistols, and this would be older high powers that have been sitting in somebody's closet for a very long time, and they go to load them, and they do load them, and they have a discharge when the slide goes forward to load the round. Or they get high efficiency cycling, I call it, where you get more than one round leaving the handgun or all of them for just one trigger pull. That happens when the Sear spring influence over the Sear gets tired and tired and tired over the years, and then that Sear lever bouncing on that Sear becomes more influential. And when you hear of those malfunctions, generally what I just explained, that's what's happening, is we don't have enough pressure on the Sear. Well, these are a long way from not having enough pressure on the Sear, you know, out of the box. But if this lever is not floating and kept clean, in other words, if it's bathed in oil and then it's, you know, subjected to a lot of the black stuff and it gets down in there, that Sear lever can become more difficult to move, and that makes a more stationary lever popping on that Sear every time the slide comes forward. And the risk of a discharge is raised, you know, just too much. This, to give you an idea just how serious this subject is, if you take a look at these two different Sear levers, the only difference is the addition of this extra metal, which blocks the firing pin until the trigger is pressed, and that makes the Sear lever go like this. The firing pin now has clearance to go home to the primer when it's smacked by the hammer. When it's in this position, firing pin cannot go forward. This has no firing, this has no drop safety. Your firing pin spring is the drop safety in the Type 1 models. But this positive, non-positively positioned Sear lever is still a consideration. When it went this way with the Type 2, there's a spring underneath it. Now, this extra mass right here, without a spring under here, this becomes problematic, because just that much extra mass hitting a Sear can cause a discharge. And it's all it takes is just that small little bit of amount of extra mass, non-positively positioned. Okay, so essentially what we found that was contributing to the non-floating floating Sear lever was a dimensional difference in that Type 1 Sear lever compared to the BH Advanced Type 1 Safety Sear lever with spring. And I'm going to show that to you right now. Here is the part out of the gun. That's the part from the Centurion 14. And this is the BHSpringSolutions Type 1 Safety Sear lever with spring. And you can, if we can get a focus, has a small little spring right there. When it's installed, what you have is, we'll try to demonstrate here. You have this. You see the sear lever popping back to its position, staying there until it's time for that sear lever to be contacting the sear. This is the fix for this Type 1 sear lever safety concern in the TISAS BR9, the Springfield SA35, and the Century Arms Centurion 14. And you have added safety margin when you add that sear lever. And virtually all of your clones that use the Type 1 sear lever can benefit also from this upgrade. The dimensional change we found different is the BH Advanced Type 1 sear lever, safety sear lever with spring, had about a 7/100th of a millimeter less width. In other words, it is freer in the channel where we want it to be or where it lives. And we had this situation where a wider sear lever dimensionally, and it creates this non-floating kind of a subject. So at this point, I'm going to ask my partner here to go ahead and take that sear lever out, and because we're going to be taking a look down in a little deeper here in just a second at the inside of the slide. One of the first things I picked up on, and we'll be coming back to the extractor area here in a bit, but one of the first things that I picked up on is, and this is the model actually that we just shot 300 rounds yesterday, so it's got a little bit of black going on inside of it. But if you can see here, we might be able to even see better here. See if we get the right light working for us. There's very, very, very little finish. This one is a good one. This I think we can really see here. Okay, the black and the silver together. There we go. Look at this area right here. There's no metal finish. There's no Cerakote or whatever they used here. And take a look down in that channel. We have no sort of metal finish or coating or anything down in this area. The non-finished part goes almost all the way. They did get, in this side area, about a 1/2 inch inside the slide, there is finish. That keeps you from seeing silver when it's assembled. Also, where you'd also see if it was not completely unfinished inside, you'd be able to see this area when assembled, and it would be silver as well. They've gotten black there, but it looks as if they have purposely not metal coated anything else inside. Possibly here, but not here. Definitely down in this channel. Definitely down in this channel. Also the slide rails. So this is an interesting thing that I don't remember us really ever encountering. Maybe we can see here. I think it'll show up in the camera. We've got some overspray. It looks here. No coating or finish there. And most of the inside of the magwell area looks like it's bare as well. So this is... this is something new. We don't know if this is a bad spray job or, an attempt to save money on Cerakote or what, but, this is not exactly what we turn out when we do a refinish out of the BH Custom Shop Service Department and the High Power Medic. One thing that we do when we do a refinish, I think is very important on high powers, is we tape these frame rails right here, and then we tape the mating slide recesses here and all the way down from front to back, and which ends about right there. And we never have cycling problems out of frames and slides as long as we keep the finish off of the frame and slide rails. We do good. And so there, we haven't noticed a necessity to keep that that micro finish out of this area, but they have. I do not believe there's anything been done to the metal here that's going to be a rust preventative, so it's going to be very important to keep a thin coat of oil. But again, don't over oil. We can't say that loud enough from our shop, because it's the number one observation we have of handguns that come in our shop is they're over lubricated. Over lubricated causes problems. And, a lot of us, for a long time have thought, oh God, you can't go wrong with, just a little more oil, and, it's going to keep things from rusting and so forth. You don't need that much oil, and it doesn't need to be ever dripping or running out of the gun or anything like that. That is a magnet for that black stuff. It causes you later problems and malfunctions and irregularities. So, but finding, the inside here, bare metal, I don't believe we're dealing with stainless. It's an observation. It's something that we saw. By the way, when we tape the slide rails and tape the frame rails before we apply a refinish, the first thing we do after that is, when they're out of the bake oven, the first thing we do is pull the tape and then cold blue those bare areas, so that we've got some kind of a protectant there on that bare metal that did not get the metal coating. Okay, we're going to run to another subject, or an observation here about the Century Arms Centurion P35. I'm going to talk about the barrels. Barrels, these look pretty basic. I was surprised that there's nothing written on them, like, at all. And so you need to keep this with the gun, because the gun does tell you what caliber, but your barrel's not going to do that. It is a straight feed ramp design, and that's fine. It's a very basic chamber entry point. It is the old design here, pre BH advanced barrel, and the crown is a what I would call a basic wrap. And for those of you who don't understand what the crown of a barrel is for, this is your last exit point for the bullet. And the idea of a uniform barrel crown is so that you don't have any parts of the barrel that are the last to touch the bullet as it's departing. And so that way the barrel releases at simultaneously the same point all the way around that bullet, and you don't get wobble, and you don't get less than true flight, when you start getting out to distances. This is a very basic wrapped crown. I don't think it qualifies as being circular. So this, from what I'm seeing, we'll just see if we can show you in a way that sort of shows that a little bit more objectively. Here's the other one as well. Take a look at the crown area. Crown areas are kind of a sensitive area of production, and they're going to have a little bit of variances when you look at one compared to another. So that is about the barrel. The recoil spring guide rod, we did notice one thing, and that is the detent ball. That's the command and control of your slide stop positioning, by the way, that goes through this loop. And the ball is definitely protruding sufficiently. I'm not sure it could be protruding slightly excessively. It isn't going to necessarily cause a problem with function of any kind. However, if it's protruding excessively now, that's could be a risk to pop out later. Just we'll have to see about that as time goes on. But it's definitely out there enough. And we have let's see, we talked about the bare steel. Oh, let's talk about dovetail sights. We're going to be checking and investigating, but I do believe that these dovetails match a Springfield SA35. At least the front one definitely does. Their contour here matches the radius of the slide. In other words, the contour of the dovetail itself matches the radius of the slide. That is a la Tisas BR9, Springfield SA35, and I think we have the same sight set again, but we'll be finding that out by seeing, can we put Springfield SA35 replacement night sights that we have from XS Sights into that slide, 3-dot white. It's they're the basic sights and they work. The frame does have, again, magazine disconnect in with the trigger. It's a traditional trigger subassembly, 3-coil trigger return spring. That's the light version, with the magazine disconnect spring also there influencing the that does help with reset, and also gives you that really raggedy gritty sound when you're going through the take-up portion as well. Okay, that's to the extent what we've gotten to here so far in these firearms. In both of these firearms, we're going to be doing some additional disassembly. I do want to cover one thing here that is important, and that is the extractor channel areas. We've kind of already been in there with a caliper and measuring things around, and I'll show you here. Maybe we can pick that up. You see that? That is some seriously ragged looking, that's the side of one of the Type 1 Sear levers that came out. And honestly, it just kind of looked like that steel had a sort of a problem, but it's kind of not smooth, and this is not going to create a good relationship in that channel where that part lives. And so, again, we just so encourage folks with any Type 1 Sear lever model that has a Type 1 Sear lever that's not positively positioned, which is all of them, unless you've replaced them with a BH Advanced Type 1 safety Sear lever with spring. Replace with this. This is an important safety margin. It keeps that sear lever from ever contacting the sear until you want it to contact the sear. It's a very, very important thing. We dimensionally checked everything going on in the extractor region of this slide compared to the Inglis. And granted, it is a Type 1 Sear lever. The Inglis is a Type 2, has different sight dovetails. These are different slides. However, this one looks like a copy of the Inglis. Everything is dimensionally, it's the same. And we believe that it is probably not sufficient to create what we would call John Browning level reliability. The real reference point is this slide right here. That is a Mark III from FN Browning, and the reliability of this particular rendition we believe to be as good as the high power pistol has ever seen in history. And so what we are endeavoring to do is we're endeavoring to duplicate, and we are, FN and Browning's entire extractor region. In other words, dimensionally conforming to what FN and Browning did in these, particularly the Turkish clones that have chronic issues in this area, and those are the Tissos BR9, the Springfield SA35, the Inglis L9A1 and P35, and we're looking at exactly the same scenario. When we were out shooting yesterday, which I believe that video footage is going to show up prior to this part of the review or the evaluation. And what you're going to see there is, and I'm going to contrast this, rewind just one step, just prior to our 300 rounds we put through this one yesterday, we shot 100 rounds through each of 3 Inglises that we used in our evaluation of the Inglis. And those all have what we call BH tuned and tested extractor region optimization. And the goal of that is to yield optimal cooperation of the extractor and all the relational aspects of the high powers extractor region, resulting in what we call John Browning level reliability and correct function. And what we saw, and it was an interesting contrast, because for most of, or a lot of that 300 out of 100 out of each of the 3 Inglises, I was standing back and I was watching really one thing: extraction distance and the trajectory of the extracting empty shell casings. And what I was seeing in these that we had done our extractor optimization on was I was watching extracting empty shell casings taking the same flight, landing in the same place, like virtually on top of each other. And with one of them, Dave was he had a 17 round magazine, and I think I just kind of popped off. I said, that thing is not going to malfunction, and it did not. And there was no way it was going to. Anything that is operating that consistently, an extractor holding that consistently every time, that the extracting empty shell casings are leaving at the same trajectory basically every time, that is a high unlikelihood to have a function irregularity or some kind of incorrect function. And then we went right to this model here out of the box that has, again, the same setup, the same dimension of parts, extractor channel, spring, extractor spring whole, everything, identical as in the English. And basically we saw what that yields, and what it yielded was, we had a couple hundred rounds there that were they did leave the gun. But if you take a look at any part of that and watch the consistency, you'll see, 3 or 4 leaving, a pretty solid direction. Then you'll see one that goes way up in the air, and one that goes like lops out of the gun, like towards the ground. And, you start seeing all these interesting flight patterns that are inconsistent out of the extracting empty shell casings. That is an extractor that is not confidently holding the same each and every time. And that is a function, that's a malfunction just waiting to happen at virtually any time. And when we started getting close to 300 rounds, we left a empty cartridge casing in the chamber, which is again a fail to extract. So we're going to be digging deeper into that subject here in our upcoming session, and we're going to be getting to that right now. Okay, we're back with the next session of the BH evaluation and analysis of the Century Arms Centurion 14, and let you know kind of where we're at. We just pulled this slide out of the ultrasonic cleaner. That's the one that we did the 300 rounds with yesterday. But I want to see, it's going to show up real good. We got a smooth machining job on the radius, top radius here of this slide, and you can see this one. There's lines in the machining, I guess you'd say, like front to back on the other one here, and that's tool marks, and that is a CNC tool needing changed out. When you start seeing things like this, it's kind of it's, I don't know what you'd say, it has a spirit of its own, I guess. But that was one observation that we had. The culprit in that 9-pound trigger pull, we just found it. This is a Browning Sear spring. I'm going to show you the profile here. There's the Century arms, and you're noticing this big arc area right here. Show you another one. This one was out of the English, and it had kind of its own issues, but definitely not the profile there. This is going to put a lot of stability on that sear. It's going to make that sear hard to move, and it's the biggest contributor we've seen so far. We looked at all the internals, and this was kind of the one standout of something different, definitely, that's going to put a lot of pressure on the sear. Now, we are never going to be able to probably say this enough, and that is, yes, you can replace out this sear spring. Yes, a Browning sear spring is going to be an improvement, or the BH Advanced sear spring set from BHSpringSolutions. Either one is going to solve this. However, job one in a Type 1 floating sear lever model is to get that thing unfloating, get it positively positioned. The BH Advanced Type 1 sear lever with Type 1 safety sear lever with spring, this is job one. It is the most important thing in any Type 1 model, especially in a model like this one where the floating sear lever was not exactly floating. Again, you start adding black stuff into that very oily environment, that less than floating sear lever is going to be becoming more and more stationary. So we are going to be very, very adamant about this handgun, and that is, do not replace this. Do not replace their sear spring with this big arc in it, even though it's putting a ton of pressure on that sear, and it's making it can stand to make your trigger brake a very hard wall to pull through. This is first. This is your safety aspect. You're adding a margin of safety. You're making it okay to then get some pressure off of the sear by going to a more proven design, and I'll show you that, the two of them, and it's definitely unmistakable, isn't it? That is going to put a lot of pressure on that sear relationship. But again, leave it be, leave it alone. Don't replace it until you've gotten positive positioning out of the Type 1 sear lever. That's really the big observation here for this session. We'll be back with the next session. Okay, guys, we are back with the Century Arms Centurion 14. We're talking extractors. We're going to try to make this a very short conversation. This is one of the Achilles heels of the high power design, indisputably. Now, I want to tell you a quick story. I bought my first high power in 1990, a Mark III model, this exact extractor in it. 19 years, 10,000 rounds, 0 malfunctions, regardless of any kind of ammunition I could find, and I fed through it. That we're not getting this sort of, I would call consistency of function quality with the extraction subject. In specifically, I can say the weakest ones, Springfield SA35, this model, and the Inglis L9A1 and P35, and they have similar approaches, and they have done similar things. There's very little difference in their extractors. And comparing them to an FN Browning, I'm comparing them to an FN Browning because this, frankly, is the gold standard. Out of 35 different high-power models and gens and manufacturers that there have been in history, this one is the gold standard, unless you go back to the internal extractor model, which is going way, way, way back. We're going to show you the differences and what's going on here. And frankly, we won't even attempt with the stock extractors on any of these 3 models that I mentioned. We won't work with them because we believe it's just absolutely a waste of time, and it's not going to yield anything positive. I will say that all of these makers, and that would be Springfield, that would be Inglis, that would be Century Arms, or the manufacturer behind the Century Arms Centurion 14, I believe they've done the very best they can with the cards they've been dealt by their reverse engineering folks. And however, it's not sufficient. and there are tangible, identifiable differences, and we're going to be talking about those here right now. Okay, first of all, the extractor in the high power design, this is a multifunctional part. A lot of people are not aware of this. This has everything to do with both feeding and extraction and consistency of extraction. And to just really explain here real quickly, your extractor lives here. You have a spring here. All the parts of the extractor that you see are just consequential to this one. This is the business area, the working part of the extractor. It's right there. That's the claw that holds onto your empty cartridge casings as the slide goes rearward, and then causes the empty shell casing to contact the ejector, and then it flies out of your ejection port, hopefully. It's positioned in the slide like this with a spring under it because this spring creates pressure on the extractor claw and the cartridge casing, and the idea is to produce effective hold. This is the part, a lot of people don't understand this also. When your slide goes forward and the breech picks up that next round in the magazine, that round then must go behind the extractor immediately. In other words, we don't have a situation where the slide chambers the round into the barrel and then this has to go up and over the cartridge casing. That does not ever happen. And if you are have any sort of practice of manually sliding around into the chamber through the ejection port and then dropping the slide, you are running a big risk of breaking your extractor doing that, because that is not normal function. It's not correct function at all. That cartridge is getting behind that extractor. The front of the cartridge meets the feed ramp, and the force of the slide going forward causes that cartridge to need to position behind the extractor claw before the slide is into full battery. So this is a multifunction part. It literally allows correct feeding, so the extractor gets positioned correctly, pinning the cartridge casing to the breech. So when we talk extractor region of the high power, it starts right here at the breech area, because your extractor lives right there, and the claw part is, the claw part is right here, if we can see that, and the cartridge casing literally gets pinned between, for lack of a better word, between the extractor claw and this breech. The integrity of the extractor claw is frankly everything. The positioning of the extractor claw is everything. And we're going to assume that The attempt here was to reverse engineer the gold standard, which would be the Browning extractor. And I want to show you how I'm looking at these three, and I know the Browning compared to the other two, and it gets kind of obvious once I show it to you here in a second. But yes, they've attempted to copy. We lay these one over the other. Pretty much the other one disappears. They're dimensionally a lot the same in a lot of ways, and it does appear that they've attempted to copy this extractor, but they've come up short. I want to kind of show you why I say that. We're going to take this dimension right here of all three. That's 7.78. This one is 7.75. That's fine. That's within tolerances or deviation. That's going to be okay. And then the Browning is 7.76. So they got this dimension copied pretty doggone well. Now, how about the position of the hole? Here's the Browning. And we're going to see a dimension. That's 0.80. So that's the dimension I'm getting when I measure with a caliper the way I'm measuring. Taking the same measurement on these, I've got a 0.66 and I've got a 0.65. So we don't have the same positioning of the hole in the part. That's a start and a change. And frankly, this is not helping. But what is also not helping is a couple of other things. You know, the old Tissos BR9 had a really defective design or machining execution on their parts. And I'm going to try to show you one other thing here, if we can point this out. And that is right here. This is, we call the body of the extractor. We'll see if we can get a little closer. This is the body of the extractor. This is the extractor claw. Where the claw joins the body, the Tissos BR9 extractors, and I'm going to say some of the Springfield SA35 extractors that we've seen, they have a 90-degree corner right there where the extractor connects to the body. When we look under high magnification at these two Century Arms Centurion 14 extractors, one of them shows a definite 90. The other one shows it does appear to have a radius. The Browning extractor under high magnification definitely does have a radius, and it doesn't have a reputation for fracture. And it's that 90-degree thing going on where this claw meets the body that creates the fracture risk and creates the weakness. And when you have a radius of metal there leading into the extractor claw, that's particularly strong and also, you know, very desirable for the longevity of the part. When we see a very aggressive chamfer right here, this shows up, I think, in the camera pretty well. This one, you can't miss it. They've really gone for this chamfer right here. That chamfer helps smooth feeding. It helps you not get hung up when the slide's going forward and it's feeding. I'm assuming they needed to make a chamfer like that. This is the Browning, and it's just a scant chamfer right there. Very, very subtle. You can almost miss it. And yeah, you can see it right there. And back to the two Inglisses, that one there is the one I think you can't miss it. Then this one is much more subtle, but watch this. It's more subtle in this area, but it's much more pronounced in this area. And what I'm seeing is that chamfer has gotten so much up into the extractor claw that it's reduced the size of the extractor claw. In fact, you can see this side comes off straight, this side comes off at an angle, but not because it was machined that way, it's because it was chamfered that way. And reducing this dimension, this is a small extractor claw, frankly, compared to a lot of the modern pistols have today. And to reduce the size of this extractor claw smaller than it already is, this is just highly detrimental to consistent and long-term reliability. And we just noticed that, you know, these things, you know, out of these two different ones, they just don't match. And they're going for something here so they can have the extractor be tighter to the cartridge, but also still feed. And that's the idea of that chamfer to begin with. But their work is highly, highly inconsistent. And even to the point where, my goodness, in this one, you can see just how it's reduced the size of the engagement area of the extractor claw with the casing. So this extractor design, we believe they've done everything that they can do with it to get it as good as they can get it. And many times out of the box, what they have done here is going to be, have some reliability for a while. Although, actually, I was just watching another video last night. I think the gentleman's name is Such. I've watched him for years, and he's a big high power guy, and he just did a review on this one. But as I was watching his shooting, it looked just like our video yesterday when we were shooting out of this same handgun. You'll see a few, extracting empty shell casings generally follows sort of the same flight path, and then you'll see one that goes way up in the air, one that goes straight kind of downward at a funny sort of a angle out of the gun. That's the reason that happens is because you don't have the same consistent, firm, decisive extractor hold happening on the cartridge each time. And the reason that's happening, or the reason it's not happening consistently each time, is because with this sort of design work and this sort of execution, it cannot. It's geometrically impossible for this to be a part that's going to hold reliably, consistently, firmly, and decisively the same way each time. And the Browning extractor is much more proven, and it's the gold standard. It does what they wanted it to do. So this is an area, and you know what, I do not want to be hard on the folks who have attempted the reverse engineering of the high power pistol design. This is fraught with all kinds of pitfalls that is possible for the reverse engineering people to fall into, and right now that we don't have time to really get into all of those, but basically we're seeing the shortcomings and the pitfalls of a reverse engineering effort with this particular design, because it's highly challenging to reverse engineer, and in the reverse engineering process, you just come out with stuff like this, and this is one place that's very temperamental, very sensitive, and it needs to be a precision-tuned proposition in all high powers. This is the one thing that it's very, very difficult to find optimal and drop in this area of the in this area of the high power. Back in the days when, I can remember when, Browning had a lot of dealers all over the country, it seemed like, and I think they still do, but not to the extent that they once did. And, they were kind of averse to selling certain parts, extractors being one of them, just to the public. They wanted those going to the service centers, to gunsmiths, people who were well skilled in tuning those parts in their guns. And there's not really so much training about how to do that, I don't think, anymore, because the model has kind of surpassed its time with Browning and FN. But again, this is one of the most highly sensitive, highly temperamental, if you will, areas in a high power pistol, and we're going to be doing the same approach with this as we did with the Inglis L9A1 and P35 models, and it is what we call a tuning and testing, extraction region optimization in the high power design, and that is something that is essential for reliability, we believe, in the Springfield SA35s, the Inglis's, and now in this one. And again, I'm not in any way knocking their product, or this isn't an objective evaluation and analysis. We saw the inconsistency of extraction yesterday, and to be quite honest, it's only a matter of time when you see extracting empty shell casings going everywhere between 1 foot away, like barely lopping out of the gun, to 9 feet away, and everywhere in between. It's never consistent, and you are shooting a fairly reputable factory ammunition, and it's just, you see extraction at times going all over the place. This is a system that's really running on the edge, and the likelihood of it continuing to function and continuing to stay reliable, running on the edge like that, I mean, hey, let's face it, sooner or later, something's not going to hold at the right time, and that's what happened. We got the firearm sufficiently hot. The tolerance between the cartridge casing and the chamber of the barrel started to get a little tighter because of the heat, and this extractor could not pull out the empty cartridge out of the chamber of the barrel. I mean, it fell out, it came right out, but it did not come out with the extractor, attached to the extractor at that time. And this and another, and a whole host of variety of malfunctions that, look like, different than just leaving them in the chamber, happen when you have a less than optimal extractor region. And we're not calling this just the extractor. The extractor region goes all the way from that breech area where the extractor claw lives and works into the extractor channel. That's where dimension of your hole placement in the part becomes influential, and all the way back to the depth of this extractor spring hole, because that's going to depend on how much that spring compresses and how much influence it puts on the tail of the extractor, which is how firm that extractor claw in place is going to be, where it's living and working, and it makes all the difference in the world as far as the quality of the hold and the consistency of the hold. So I guess what we're showing to you right here, this is not anything new. This is, as far as we can see, it looks like the same dimensions all over the place as we found in the Inglis. It has some similarities to the Springfield SA-35 situation in the extractor region in those guns, but it's not quite identical. And we can handle this, and we've already handled it in the Inglis's. We're going to handle it here in these two Centurion 14s, and we're going to have shooting that's going to show the difference in the flight path of the extracting empty shell casings and what consistency that you can believe in, that where hey, this is reliable enough for my holster or my nightstand or whatever it is. That's what you're looking for in a handgun that is used for anything except just punching holes in paper. And that's really what we specialize in, is serious use of handguns, especially the high power design. And so that's our report about the extractor situation here. I do totally believe that based on the parts, based on this construction of the entire extractor region in this handgun, the Inglis, and in the Springfield SA-35, these manufacturers are getting the best performance that they can out of the parts and out of the combination of dimensions in the extractor region. They're getting the best they can with the cards that they've been dealt. And the good news is that this is optimizable. This can be handled, and yes, these handguns can exhibit reliability and correct function that is every bit on par with the FN Browning Mark III high powers that we do believe are the class of the field still today, and especially and one of those things being reliability. These have the capability. In other words, we can, at BHSpringSolutions and the High Power Medic, we can get that, what we affectionately call John Browning level reliability out of these handguns. But it takes optimization, and it takes some corrective measures in this extractor region in order to optimize this system. And then the result will be on par with what we've experienced out of the FN Browning Mark III high powers. Okay, folks, we'll be back with the next session.